different deep learning models. Myself, Vedi Vigilan, from Department of Computer Engineering, Government Engineering College, Wayanad, and it is affiliated to Kerala Technological University. I am a part-time research scholar at this institution, and my guide is Dr. Anita V.S. Actually, my paper refers to the uterine disorders that can be various models in a deep learning approaches are applied, different performance measures are used for the comparison of these deep learning models application. So uterine disorders, we know that it significantly impact women's reproductive health and overall well-being, and it is a potentially life-threatening condition. It lead to very risk factors to female. So in advancement in personal treatment option, there is a need of multidisciplinary approach to manage these life-threatening conditions. So here we are using different deep learning models are applied for the finding out of uterine disorders, specifically PCOS. PCOS dataset is used for this research purpose, and different performance measures such as accuracy, precision, recall, confusion metrics, FN score, and execution time are used for the comparison of the results of these deep learning models. Then we know that PCOS is a hormonal disorder, which is actually common in reproductive age of the women, and the hormonal imbalance is likely influenced by genetic factors, and the symptoms of PCOS are irregular menstruation, androgen levels are elevated, and ovarian cyst, etc. And this may lead to risk of type 2 diabetes and cardiac related diseases. So it leads to risk of obesity, infertility, and depression and anxiety. So this paper details various researches undergone in diagnosing uterine disorders using deep learning approach, and there is a comparative study been performed in finding PCOS disorder from ultrasound images. So the modality used in this research is ultrasound images, and different modalities are there: MRI, hysteroscopy, ultrasound, etc., for finding out these anomalies of uterine. But here, in this research, we used modality ultrasound images. So we know that deep learning is actually a subset of machine learning, and it helped to learn the patterns and predict from the image data using artificial neural network. And deep learning has actually it has a major role in the diagnostic field. So our aim is to identify the PCOS disease from the dataset. Here we are using Kaggle dataset, and it is freely available in the Kaggle website. And before applying these deep learning models, several pre-processing methods are applied. Augmentation parameters and augmenting techniques are applied to these images for the standardization and normalization. And images are first of all rescaled So the training process will be more stable and faster. And we have used 80% from the data set. We have used 80% of data set for training and 20% for the validation purpose. And rotations are performed up to 20 degrees, and images horizontally shifted to 20%. This helps the model to handle the horizontal translation in the images. And small vertical shifting also performed as pre-processing technique, and randomly shared the images to be randomly shared. So this will help the model to be more robust to distortions. And this is randomly zoomed in or out up to 20%, and randomly flipped horizontally and vertically also flipped. So these pre-processing methods are performed in the images, and after pre-processing technique we performed this will help to perform an unbiased evaluation, and different deep learning models are applied to this data set and performance measures are calculated. So a Kaggle website data set is used for this work, and it is mainly classified into two classes: infected and not infected under EPCOS category. And the different models we have applied into the data sets are VGG, ResNet 50 V2, MobileNet, Inception V3, etc. And the performance measures used in this work are precision, recall, accuracy, FN score, confusion metrics, and execution time. Accuracy means it is the ratio of correct prediction to the total instances. It checks the correctness of the model. And the precision is the ratio of correct predictions to the total predicted positives. Recall is the ratio of actual positives to all the observations in the actual class. F1 score is the mean of harmonic mean of precision and recall. Confusion metrics, actually it's a table, provides a view about the correct and incorrect classification. TP means true positive, TN means true negative, FP means false positive, FN means false negative. And the execution time is the total time taken by the system or a process to complete the classification task. That is prediction. And this is a table about the comparative study of performance measures of various models. And we have finally, after applying this PCOS data set into various models, most of the model perform the same accuracy, precision, and recall, but the execution time is found different for different models. And we found that MobileNet is found better performance than other models while considering the execution time. And while comparing the MobileNet model with the least performing model, it has 300% better performance than the least performing model. And the future work can be made improving the execution time with 100% accuracy of the prediction based on the performance measures. And the references I have used in this paper is follows. Thank you.